So this is examples class 8. Examples class 8 on tests of hypothesis, single sample tests. And this week in the lectures, we've covered the hypothesis test procedure and gone through how to formulate hypotheses on which the hypothesis test depends, and described the hypothesis test process, which we'll come back to over the next few weeks. Formulating null and alternate hypotheses in words have been part of the problem for this week, and we will be covering that in this examples class today. So why do we do these tests? And of course, mostly it's in order to determine whether a claim made by a manufacturer or by an advertiser or by a researcher can be upheld, or if that claim is no longer appropriate. So the reasons for testing, as we saw in our first lecture this week, lecture 15, are to determine whether a claim is reasonable. Similarly, in research, we often see things that are put out into the media that determine for us whether we want to make a test to see if that claim is reasonable. And those tests we looked at also in lecture 15. When we were identifying the hypotheses as the first part of our problem, our first example contained information about a claim made by a manufacturer of juice drinks that their juice drink contained, on average, 7.5 milligrams of vitamin C. And of course, this kind of claim is really important. Often we don't, we want to know if that's a reasonable thing to say, because people are buying those juice drinks on behalf of the fact, or using the fact that the vitamin C content is what they're buying it for. So when we're making a test of this, what we need to look at is whether we are seeing whether the population mean can reasonably be suggested to be 7.5 milligrams, or if that's an incorrect claim. Now that example I covered in lecture 15. Today we'll look at a few further examples. And the first of those is the one that we're seeing here. Is the population average amount of TV viewing equal to 12 hours? And when we're looking at those hypotheses, what we consider is the statement of that question. Is the population average equal to 12? And we write that down. For the population average, remember, we use the symbol mu for population mean, or we can write that in words. So our question, statistically, is the mean is 12. And our alternate, the complement of that, if we say the mean is equal to 12, the opposite statement is that the mean is not equal to 12. Now remember, the important thing to think about at the start of these problems is that from here we select the alternate hypothesis, which will be the statement which does not contain the equal sign. And that one, of course, is the mean is not equal to 12, which then gives us our null hypothesis, which will be with an equal sign, mean equals 12. And we can write our hypotheses, and the normal way to do this is to write the statement of hypotheses, null hypothesis, mean equals 12, followed by alternate hypothesis, which sometimes has the symbol H1. Alternate hypothesis, mean is not equal to 12. And that alternate hypothesis with the inequality symbol tells us then we'll be doing a two-tailed test. So those hypotheses are what we start with and what the whole process will come back to when we finish. Second example. Again here, we're considering the statement made in the problem is the average number of correct answers at least 10. See, in a problem like this, and I'm looking at information from tutorials, I want to know if people are reasonably finding the tutorial questions doable. So I want to know if the average is at least 10. I'd be concerned if it was fewer than 10. But if it's at least 10, I know that some people are at least understanding what I'm talking about. So I state the question statistically, which is that the mean is equal to or bigger than 10. At least 10 means greater than or equal to, which means the complement of that, the rest of the number line, is the mean is less than 10. So that's my concern. If the mean is less than 10, I'm not doing a good job. So from here, going back to the idea of selecting the alternate hypothesis, which will be the one that does not contain the equal sign, we select the alternate hypothesis as the mean is less than 10, and our null hypothesis then will contain an equal sign and write the mean is equal to 10. So again, just to finish that off, the hypotheses on which we base our problem will be null hypothesis, the mean is equal to 10, and the alternate hypothesis, the mean is less than 10. So the hypotheses are the very first thing that we do in our problems. So now moving on from here to look at one further example where we're considering two sample tests, and next week we'll be looking at more problems that involve comparing two populations. So far we've just looked at one sample from a single population. Here we're making a comparison between men and women. So we're interested in comparing those two populations. Here we're seeing a research hypothesis is that women talk more than men, which of course is untrue. But what we begin to think about is whether there is no difference. Remember, null hypothesis is talking about the word no, zero difference. So really we're looking to see, is there a difference between these? And a difference we write mathematically by using a subtraction symbol. So the mean for women minus the mean for men equals 0 is the same statement as the mean for women is equal to the mean for men. Now, when we are stating the complement of this, we have to go back to the idea of, do women talk more than men? So here we'd be looking at, do women talk more than men? The mean for women bigger than the mean for men. And of course, if that is not true, the complement of that would be the mean for women is less than or equal to the mean for men. So when we're writing our statement for the alternate hypothesis, this will be the mean for women is bigger than the mean for men, or the mean for women minus the mean for men is bigger than 0. So the bigger value will be the mean for women. And of course, our null and alternate hypotheses there, mean for women minus mean for men is equal to 0. For the null hypothesis, mean for women is bigger than the mean for men, is bigger than 0 for the alternate hypothesis. So the important thing to note here is that this expression on the right-hand side that I've crossed out here, this is a two-tailed hypothesis. It means we're concerned with both ends. The second, the one that we're using here, is a one-tailed hypothesis. And we've seen a little bit about the difference in those two things and how we look at rejection regions. We're doing a few more of those in this examples class.